So let's get started. Okay. Now, before I start, I just want to go through with you what we'll be doing. Okay. So I will skip the man-made satellite. Okay. Why? Because I think satellite so far is a factual thing. So this one you can read yourself, you can learn how to calculate yourself. So this one shouldn't be too big of a problem. All right. And also, if you want to do a very special satellite question, right, guys, you must go watch my YouTube, right? There's this part whereby at the back part, I did a 2023 punya trial SPM trial punya satellite question. That one very special. Okay, you should go and have a look. Now, so if you look at this today we are going to focus in wave first. So this is like the first half. All right. So we're going to do interference of wave. Later on at the back part, we are going to go into light, which is length calculation. And then after that, we will end our day with a bit of Archimedes principle. Okay. Now, why I don't want to do the force and motion part later, I'll tell you why as well. Okay. Now, so children, this is English class hall. Mandarin class is Thursday hall. Okay. Now, so if you guys got no problem, then jom, let's start. Okay, for interference of wave, right? So first of all, you must always know what is wave first lah. So sekurang-kurangnya, you need to know the wave properties. Okay, guys, I give you a very interesting question. Okay, so if I draw a graph like this, usually in exam, they will give you a wave like that. Okay, let's say wave like that. Okay, can you tell me what is this thing called? Okay, we warm up first because in wave, you have to know all the terms. So from this 0 point, this part, what do we call this? So this is actually known as the what? So known as the amplitude. So this is the amplitude of the wave. Of course, when you go down, there's something called negative amplitude. So sekurang-kurangnya, the first thing you have to know is amplitude. Okay, next, number 2. Okay, once you know this is amplitude, all right, inside A and negative A. The second question is, they will ask you, so from this starting point to this point, okay, what is this called? Okay, so many people will not be able to answer this question, okay? Can you tell me, if I draw a graph like this, so this part 1 complete wave like that, what do you call this as? What do you call this as? Okay, got people say wavelength. Got people say period of wave. Okay, the answer is, for this one, there is no answer. Okay, why no answer? Because most of the time when you look at this thing, right, it depends on what your x-axis is. You tahu tak? Okay, for example, actually, right, for wave, there are actually 2 types of graph. Okay, the first type of graph maybe is in terms of t, then /s, time and a second. So the second one is maybe distance / meter. If this is the distance / meter graph, then this is called lambda, known as the wavelength. If this is the time second graph, then this is actually your period of oscillation. So you cannot, right, when you look at this graph, straight away thinks that this is the time ke ataupun the wavelength ke. You must depend on what is the paksi, what is the axis, okay? So make sure you are aware of this thing. So this is time punya wave, the left-hand side one, and then the right-hand side one is the wavelength, okay? Now, of course, in this chapter lagi, I mean, in the introduction to wave, of course, we have this thing called frequency, whereby frequency we calculate by using 1 over time, and then we got wavelength time, and then after that, 2 more special terms. Okay, guys, the highest point of a wave is called what? The highest point of a wave, all right, that is called C, starts with C, so we call that as a crest. Then the bottom part of the wave is called what? It's a T, which we call it as trough. So some people say, teacher, very confusing. Crest and amplitude, what's the difference? Okay, amplitude is the height, ketinggian. Like let's say, for example, amplitude is the height of it, okay? Then the highest point is called the head. So that is the crest. So crest is the name of the point, amplitude is the name of the height. So don't get confused, all right? So crest and trough is the name of the point, amplitude is the height. Okay, so the first few things is you have to know is crest, wavelength, trough, time, frequency. Okay, about 1, 2, 3, 4, 5 terms first. So if you guys got no problem, then jom kita tengok . Okay, so at this part here, you will see that we have this so-called formula. So the formula is to calculate what? This is actually to calculate lambda equals to ax over d. But before we even look at the formula, we need to know what is a wave interference dulu. Okay, a wave interference mainly is you have example. Okay, I give you this example. Example now, we look at a swimming pool. Okay, we look at a swimming pool. So if Jung Hao, let's say, and another friend, we jump into the water at the same time, so we both jump into the water at the same time, you will see that Junghao will produce a water wave, correct? All right. Now, then after that, the other friend go out, the wave will also produce a water wave. So these two waves will actually intersect each other. But remember, we don't say intersection of wave. The two waves will intersect, but we don't say intersection of wave. Tetapi we call this the interference of wave. So it is something like intersect of wave. So when these two waves go out, they crash into each other, like that, right? Okay, got how many different possibilities? Can you imagine? If let's say now I've got this wave moving towards this direction, and let's say I've got another wave also moving towards this direction. So you realize that these two waves will bang each other, right? So now we got this thing called a crest, this thing called a crest, this thing called a trough, this thing called a trough. So now when they crash into each other, we have three different possibilities. So the first possibility is ngam, the head and the head, the crest and the crest, they langgar each other. So at this point, this is the crest-crest intersection, the crest-crest interference, all right? So when you have a crest and a crest langgar each other, right, correct? So what will you produce? Okay, so there's this thing whereby you must imagine, okay, if you have a high wave and a high wave, when you langgar, you will get obviously a larger wave, right, correct? So when you langgar, you will realize that the crest and this crest actually langgar each other. So you will form two crests. And imagine if this is amplitude, this is amplitude. So when these two crests bubble, when they langgar each other, the amplitude here is actually 2A. So you will actually plus the amplitude together. Okay, so now tell me, do you get a big wave or a small wave? So obviously it's a big wave because it becomes bigger, right? Okay. Now then number two. So you can imagine this is something like you have a wave like that, you have a wave like that. So when they crash towards each other, boom, you get a larger wave. For example, you get a larger wave. Okay, what about the point Q? Okay, at point Q, now is terbalik already. You are going to have a trough and a trough langgar each other. Okay, so when you have a trough and a trough langgar each other, what will you produce? Okay, so first of all, this is negative A, negative A. For people who came in late, A stands for amplitude, boleh. So negative A and negative A, they langgar each other. So meaning to say that I have like a bottom wave. Okay, because wave is like this, right? Correct? I have the bottom part of the wave. Langgar the other bottom part of the wave. So they actually form a wave which is slightly more deeper. So negative A, you actually produce a wave of negative 2A. You actually produce a wave of negative 2A. So now, let me ask everybody here. Okay, is negative 2A considered a bigger wave or a smaller wave? Is negative 2A considered a bigger wave or a smaller wave? So what do you guys think? But it's negative 2. Is that like a bigger wave or a smaller wave? That's considered a bigger wave as well. Okay, remember in physics, right, we focus on the value. We can't focus on the positive and negative sign. The negative signs only indicate that it's moving in the opposite direction. Okay, so we also get a bigger wave as well. Okay, now these two, because they form bigger wave, they join satu gang. Okay, gang apa ni? So this is called the constructive interference gang. They are the constructive interference. Alright, so you actually get a bigger wave. Now I'm gonna ask you guys to like make sure remember this definition now. Okay, in this interference part, right, there's actually a very special principle. Now this principle, walaupun it's not in this book, but I think it's important because sometimes exam will ask you this definition. Is the definition very hard to remember? No. Okay, what definition is it? It is called the principle of conservation. No. Principle of conservation. Sorry, teach too much for it. Principle of superposition. Okay, make sure you know this principle of superposition because they will ask you the definition one. Now I can just agak like tell you lah. So superposition means that when these two waves langgar each other, the amplitude will be added together. Means this amplitude and this amplitude will add together. That's why A become 2A. Then negative A become negative 2A. All right, so this is on the principle of superposition part. Okay, next. Then we'll look at point R. So for point R, this is a total different situation, because now you have a crest and a trial, they actually come towards each other. So it's something like you have a positive wave like that, the crest, and then you have like a negative wave, they langgar each other. So at this point, don't say that there will be no wave form. We usually say that you form a smaller wave. Walaupun these two crash into each other, they hilang, right? But we don't say no wave, we say smaller wave, okay, lesser wave. So this A and this negative A, when they langgar, your amplitude becomes 0 because it's like 1 plus negative 1 means 1 minus 1, you get 0 lah. So this is what you will get, 0. Okay, so now the keywords here are your constructive interference, destructive interference, and then your 2A, negative 2A, and 0. So anybody got any question up until this point? No? No? Okay, then we talk about some common mistake. Okay, here there is a common mistake, which is what you know. People tend to always forget there is another term called antinode and node. Okay, see here, they tell you what antinodal line, nodal line, antinodal line. What is this antinode and node? Now, first of all, antinode and node, they are both the name of the point of your interference. So antinode is actually the name for constructive interference, is antinode, and then node is destructive interference. Okay, why I say this is quite confusing. Kadang-kala sometimes, some people will think that, destroy, destruct. Destroy means anti kan, because if I anti you, like I don't like you, I will destroy you, right? So people thought that destructive is antinode, but it's wrong. Okay, how I remember this is, I remember that if my wave is bigger, the word is longer. If the wave is smaller, the word is shorter. Okay, what is the name of the smaller wave? Which smaller wave? You mean what? This one? Okay, so this one, right? If they ask you what is this point, okay, there's no name one. What is this point? We'll call it as a node. So this point dipanggil sebagai node. What happens at this point is destructive interference. Alright, like for example, this point also got no name one. This one also got no name one. We will just say that this is antinode, the point of antinode, and constructive interference occurs. Okay, why? Because you got crash langgar, macam tu saja. Okay, can? Alright. So why I spend so much time talking about interference is because this in your exam, if come out right, because there's so much things to study. So today I'm going to share with you what do they usually ask in the exams. Okay, because there's like so many pages, right? So many theory, right? So biasanya, which one do they ask? So that's the secret here. All right. Now, so let's look here. Okay, what's the meaning of coherent source? Okay, so in interference, for these two waves to happen, guys, these two source, which is called the sumber of the wave, has to be coherent, meaning to say that these two waves must be produced at the same time. These two waves must be produced at the same time. So they say what? Same frequency, same wavelength, same amplitude, and in phase, phase difference, right? Okay. Now the most important thing that you have to say is same frequency, this one, and according to your textbook, they will write same phase difference. Okay. So whether you can remember the same amplitude in phase, this one is actually optional. All right. Most important is same frequency, same phase difference. Most important is same frequency, same phase difference. Okay, okay. Now, so what you have to look here is what is the meaning of coherent source? Okay, we try to think of it this way. If you want to produce a interference of wave, okay, now I ajak my friend. Okay, if you guys know who is Davin is the bio teacher. Okay, Davin Yang. So I tell Davin that, hey, jom, let's produce this wave. So the first guy jump out will produce satu wave. The other guy jump out will produce the second wave. They will intersect each other. So, but when I told David, this guy, I purposely prank him. So I like, hey, we count to 3, then we jump into the water at the same time. So I told David, like, okay, 1, 2, 3. So David actually jumped into the water already, but I didn't jump. Okay, so what happens here is David actually produced, a wave already. So this wave keluar, move forward. Then 3 seconds later, baru until my turn, right? then only I jump into the water. So meaning to say that I jump a few seconds later, like 3 seconds later. Okay, so now guys, will these two waves interference or not? Will they interfere each other or not? So one in front, one behind. So the both waves will move together, right? So will they end up interference with each other? Will they end up interfering with each other? So obviously, no. The answer is no. Why? Because one is in front, one is behind. So the two waves will move like that lah. Okay, what you need is, I need David to jump into the water with me at the same time, baru these two waves can like interfere each other. So these two waves must be produced at the same time. So when we say this same phase difference, it is something like same time like that. Something like that, okay? To be more detailed, we have to explain by using calculation, which you don't learn in calculation in SPM. So this same phase difference is something like same time, okay? Next, okay. But if today I didn't find David to do this experiment with me, I found another guy. So let's say now, instead of Junghao with David, I found Wailun to do this experiment with me. So there's another guy. My other friend is called Wailun. So what happens here is that if Wailun play this game with me, when he jumped into the water, okay, you will realize that he actually produces lesser wave. Let's say he produced only 2 waves. Because when he jumped into the water, boom, bloop, bloop, only like 3 waves. So do you think these 2 waves will produce interference? Will they intersect each other? The answer is yes. But do you think you will produce this or not? No, right? Because here got 4 waves, here got 3 waves. So the wave number is not balanced already. So if it's not balanced, you are not going to form such a perfect intersection. So meaning to say, these two guys, punya wave must be identical. But remember, we cannot say identical wave. We have to say coherent source, meaning to say that these two must have same wavelength, same frequency, and everything. Okay. If exam you lupa to write same amplitude and in phase, if you forgot to write this one, that's fine. But most importantly, same frequency, same wavelength, same phase difference. Okay, can faham? Okay, so then we go into the anti-nodal line and nodal line. Okay, so they like to ask you what happened at the anti-nodal line and nodal line. Okay, so now we focus on the word antinode first. Antinode, tadi we say, is your constructive interference. Constructive interference occurs when you have a crest langgar the crest, when you have a trough langgar the trough, correct? You have a crest langgar the crest, you have a trough langgar the trough. So what happens here is that constructive interference occurs, antinodal line. It happens when you have a crest langgar the crest, or you have the trough langgar the trough of another wave. Okay. Now here there's a word very haram lah, okay, nowadays, is we don't write the word coincide anymore. We will say that it undergoes superposition with crest of another wave or trough of another wave. Coincide is not a scientific term. Okay, so can you just help me to change that term for a while? Yeah, can So, and then nodal lines is the destructive interference, because your node is the destructive interference. So occurs when the crest of a wave, don't say coincide. The answer is, the word is superposition with trough of another wave. Okay. So in physics, right, keyword is very important. Okay, all right. Now, so I know some of you are probably new students here. All right. Hello, everybody. Okay. I just want to remind everybody one thing very important. Okay. In physics, remember, paper 2, right, guys? How many % is theory? How many % is theory? How many % is calculation? Okay, anybody want to guess? 50-50? Okay, obviously some of my old students, you all can answer this question now, but today we have like probably like 4 to 5 new people. Okay, so we just try and inform everybody. So what's the theory to calculation ratio? Agak-agak. Okay, you must remember, theory to calculation is about, calculation can range anything from 22 to 24. So let's just take average 23. So calculation theory is 77%. So the secret here to produce good results is to aim theory. Okay, can? The secret here to produce good results is aim theory. All right, can I? Now, so remember that you have to do all this word stuff. Okay, for the relationship between X and something, okay, we'll come back that later because you still cannot faham what this is at this point. Tak penting dulu. Okay, let's look at the sound wave interference on the next page. Okay, on page 3, you will see that here we're going to talk about something called sound wave interference. Okay, because why tadi is water wave. Now, to find water wave interference, we can use I and C. Why? Because if you see the wave is bigger, this is crash. If the wave is deeper, it's a trough. If the wave becomes flat, it's crest and trough. But sound, how can you tengok sound? Can you see sound? You cannot, right? Correct? So if you cannot see sound, then macam mana to detect where is your crest trough or trough. So the answer here is this. For constructive interference of the sound wave, we judge by listening to the louder sound and the softer sound. All right. Now, for the louder sound, it's usually compression rarefaction. Okay, tiba-tiba you have this word. Your teacher, what is this compression and rarefaction? Okay, so we warm up with this thing first. Okay, what is this compression rarefaction? Now, how many types of wave do we learn in our syllabus? So we generally learn 2 waves. Okay, so the first is called what? Transverse wave. The second one is called longitudinal wave. Longitudinal wave. Okay, so we got 2 waves. Now, is sound transverse or longitudinal? Is sound transverse or longitudinal? Okay, give your 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, the answer is jeng. Okay, the answer is longitudinal wave. In our syllabus, we only would learn 1 longitudinal wave. So that's why, right, for me, my strategy is I remember like sound is longitudinal wave. Then after that, everything else is transverse wave. Okay, remember, guys, according to our syllabus, if you find like let's say Google, right, there are like many longitudinal wave. But in our syllabus, we only focus on sound as one of it, Saja. Okay, can? All right. Okay, now once we are done with this thing, okay, then we go to the next part. Okay, so how does sound move? What is longitudinal wave? Okay, bayangkan, now we got 2 people. Now imagine now Jung Hao is trying to talk to Ziling. Okay, so I'm trying to talk to Ziling. So initially, in between me and Ziling, we have air molecules. In between me and Ziling. Okay, so what happens here is that the molecules are evenly spaced. Okay, what do I mean by evenly spaced? So you see the distance of each molecule is like, okay lah, got gap here, got gap, they're all evenly spaced. But suddenly, when Jung Hao starts shouting, it's like, oi, Ziling. So if I shout like that, right, okay, what happens? So the molecules will start to shuffle. So some molecules will come together, some molecules will come together. So what you will form here is something like this. So these molecules will come together, this one solo, maybe these molecules will come together, and then one more here solo. Okay, let's say something like this. Now, you see that some of the molecules will become compact, one will be alone, then compact, then alone. Okay, so what happens here is we say that we actually form different regions. C stands for compression. Okay, what's the meaning of compression? Means that your molecule actually come together. So that's compression. So you see, your molecules actually form together. Your molecules come together, so they form a compression region. Okay. Next, what about rarefaction? Rarefaction is usually when your molecules actually move away from it. So that's your rarefaction region. So why is this very important? Sometimes your teacher will draw this, and then they will call you to draw where is 1 lambda. Where is 1 lambda? So 1 lambda means 1 wavelength, right? So to find 1 wavelength, we usually take 1 compression, 1 C value to the next C value, ataupun 1 R value to 1 R value. So this is your wavelength, this is also wavelength. So we like C to C or R to R. Okay, boleh C to C or R to R. Okay, once you are done with this thing, okay, C to C, R to R. Okay, so we will form our compression and rarefaction region. Compression and rarefaction region. Then yeah, okay, we can now look at this thing. Okay, so far anybody got any question? So far anybody any question? No question? Okay, then we continue the next part. Okay, so when I've got two compression, okay, let's just say compression is actually A and A when they lambda, you actually form 2A. Let's say rarefaction is negative A. Let's say amplitude negative A. So you realize that this is negative 2A. So tak kisah whether you have 2A or negative 2A, you get bigger wave, right? Remember just now we said, when you have 2A ataupun negative 2A, these are both considered big waves, correct? So when you have 2A and negative 2A, you actually produce a loud sound. So meaning to say, if you take a microphone here and you walk along the line, you will realize that your mic will suddenly hear a loud sound, means constructive, then soft sound means destructive, then loud sound, constructive, then soft sound, destructive. So this is what you will get when you form here. You will have a loud sound, soft sound, okay? And then after that, a loud sound, then a soft sound, then a loud sound, a soft sound macam tu. So this is what you will observe. Okay, can all right, so this is the more on the theory or the introduction part on the interference of wave. Okay, we use half an hour to do this. Now I will go into the calculation part for this part. Okay, the calculation for this question, right, is actually not scary. It's actually not scary. Why? Because usually they'll give you the value, and then after that you just count, sub value, press calculator, you get your answer. All right, but the most scary part is they like to ask you this one. What happens, the relationship of XR and AR and D and everything? Okay, you see, okay, so, but before we go into that, you have to know what's lambda first. So lambda is wavelength of the wave. So this one, no problem. What is A? A is the distance between your two coherent sources, meaning to say that your two going out punya wave, let's say here, for the sound one, is 1.5 meter. Okay, so according to this part, lambda equals to AX over D. So the A is going to be my 1.5 meter from one speaker to the other speaker. So that's my A value. Okay, then what about my X value? X value is the distance from the loud sound to the next consecutive loud sound, or the distance between from your soft sound to your soft sound is also X. So it's either from the loud to loud ataupun from the soft to soft, which then you will get the X value, Okay, Ken? Okay, so what about D value? D value is this. This is the D value from one wave to the next wave. Okay, from one wave to the next wave. That's your D value. I mean, sorry, from your source to your screen, or from the starting wave to the ending wave. So that's the D value. So now what you get here is your calculation already. Okay, now then what's next? So they like to ask you, okay, if now I change my A, what will happen to my X? If I change my D value, what will happen to my X? Okay, you all have a look here. Okay, they really write very nice for you already. So according to lambda equals to AX over D, they will say what will happen to X. If A increase, X will increase or decrease. So according to the answer here is X will decrease. Okay, let's just have a sea of hands. Anybody here don't know how to tengok this thing? Siapa tak tahu how to tengok this thing? Okay, because I'm going to be very honest. When I was Form 5, I don't know how to see this thing. Yeah, so at the end, I invented a very weird way. So what I did last time was AX over D. So I put numbers into it. So what I did here was I put like, let's say 100 is my lambda, A is my 10, X is my 10, D is my 10. So this is lambda AX over D. Now, so why I do this? Okay, because I don't know how to see pindah what denominator, numerator, because my maths wasn't very good. Okay. Now all I want to know is, okay, what will change? Let's say if A increase, my X macam mana? Okay, so I try lah. Okay, so A is now this one, right? So my A increased to 20, X equals to how much? So I will start calculating. So I press calculator, 100 times 10 divide by 20. I realized that my X is equals to 5. Everything started at 10, correct? Now my X become 5. So means to say that my X actually decreased already. Means my X actually decreased already. Okay, you all faham how I do this, right? I just change the value inside. So let's say, okay, we go back to 10, 10, 10. So 10 times 10, 100, divide by 10. I write wrongly, sorry. It's all 10, 10, 10, 10, 10. So 10 times 10 is 100, divided by 10 is 10. Okay. So now, okay, demo one more time, AX, okay, if my A is now 20, how much is my X? So I calculate, shift everything, so my X equals to 5. All right. Next, if now let's say my D increases, what happens to my X? Okay, so I put the 10, 10, 10, 10 again, 10, 10, 10, 10 again. So if now D is the bottom one, right? The bottom one, right? So if my D increases to become, let's say 20, okay, can anybody tell me my X will become how much? So 200 divided by 10, it will become, X will become 20, right? So which means that my X will increase. So I use a calculating approach to solve this thing for me to see. I use a calculating approach, okay? So, but anyway, guys, it's up to you what is suitable for you, all right? Okay? So, you see, I used my calculating approach to get my AX, DX, and so on. Okay, Ken? Now, once you are done with this thing, okay, we are going to look at the next part. Okay. Okay, now we're going to look at the next part. So we're going to go all the way here. Okay, what happens to the pitch of the sound? Okay, once we look at the pitch of the sound increases and everything, okay, now we talk about two things first. Now, do you guys know what is the difference between loudness and pitch or not? Okay, can you differentiate what's the difference between loudness and pitch? Okay, so loudness usually means that how like loud the sound is, okay, literally loudness sound. Then what pitch does it, what does pitch means? So pitch actually tells you how like sharp the sound is, how sharp the sound is. So in this case, what affects the loudness? So the loudness is usually affected by this thing called the amplitude. Then what about pitch? Pitch is usually affected by this thing called the frequency. So amplitude will affect your loudness, frequency will affect your pitch. Okay, so these are the affected stuff. Okay, next. So what happens when pitch of sound increases? So obviously when your pitch of sound increases, your frequency definitely will increase up. When your pitch increases, definitely your frequency will increase up. Okay, once your frequency increases, what will happen? Okay, so now we have to look at the formula. Lambda equals to AX over D. Then after that, in this chapter, there is also one more special formula, which is V equals to F lambda. So when your frequency increases, what will happen to your lambda, guys? When your frequency increases, what will happen to your lambda? Your lambda will what? Increase or decrease? So the answer is it will decrease, right? Correct. What you can think of is when your frequency is higher, means that your wave is like more like this, right? So meaning to say the distance between your wave, okay, imagine say like this. So the distance between your wave will become shorter. So once your wavelength decreases, it means that your X value will decrease. So basically, you just have to explain this thing. So when the frequency increases, the pitch of sound increase. So your wavelength will decrease based on the first formula. The second one, so when your wavelength decrease, your X will decrease. So the distance between loud sound, soft sound will decrease. This is actually means that your X will decrease. Okay, Ken? Now, some teachers here, they want special word. They want to say the distance between consecutive loud/soft sound will decrease. Okay, so the distance between the consecutive loud soft sound will decrease. So this is a very important thing. Okay, if you can write better answers, because who knows, your teacher might be the very demanding teacher. Okay, can all right, very good. Okay, remember guys, I want to finish this wave in 45 minutes. Okay, we are almost halfway through the class already. Okay, the time actually passed very fast. Okay, for light wave interference. Okay, now before I continue, okay, I'm just curious. So for those people who are today first time attending my class, right? Correct. May I know what school are you guys from? So let's say I think Shakira, your first time, right? Like which school are you from? Clarissa or SMKKK. All right, cool. Which means Kota Kemuning, right? I assume KK. Yeah. So yeah, because Selangor, okay guys, Selangor, okay. Selangor came out interference of this wave for your last year punya Form 4 final exam. Okay. So if you guys happen to be in Selangor, mungkin you did the sound wave interference. It was building a concert stage. Yeah, I don't know which school because there's set A, set B, but if you are from Selangor, there is a high chance that you have done this question. Okay, and I heard many people didn't do well in that essay question. Yeah, that's why we did this thing today. Okay, can now, so as for light wave, okay, I mean like, what about other people like Jack? Yeah, okay, can. Which school are you guys from? Okay, now let's look at light wave interference. Okay, for light wave interference, ini apa? So the same thing. Just now we use sound. The sound go out. They cancel each other out. Water also they interference with each other. Light also sama. When this thing goes out, they will start to form this thing called interference. So they will sort of like intersect each other. Okay, they'll sort of like intersect each other. Now for this intersect with each other, you will realize that for like a bit lecture, they want to make this become a single slit first before going into this double slit. They want to put this across the single slit dulu before going to the double slit. Okay, why? Okay, because study we said, why do you want this to form a diffraction first? Okay, this single slit is to ensure that the source at double slit is coherent source. Okay, because you see, light very sensitive. We need this wave that comes out from the double slit here to be identical from each other. To be identical, they must start from the same time lah. They must be the same wave lah, everything. So macam mana? They purposely use from one slit to go into this double slit so that this two wave that comes out at the double slit is coherent source. Okay, can? All right. So this is very important to ensure that the double slit here, you come out is identical wave. Okay, but for light, there's another one more mafan stuff, is you need to use a color filter. It's not necessarily like blue, but what you need here is a color filter. Okay, why do we need color filter? Just curious, do you all do this experiment in school? Do you all do this experiment in school? I don't think so, right? Oh yes, or you all did this experiment in school? Okay, now if you got do this experiment before in school, it's quite fun one, okay? Now, but before I show you the fun part, okay, I want you guys to just have a look on my screen here. Okay, if you see on my screen, you will realize that if you use different colors, you will see that there will be different thickness. Do you realize that? Okay, obviously red color being the thicker and everything. Okay. Now, but we look at this one first. Okay. Now, if you use white light, right, you will actually form a rainbow pattern. Okay, we don't usually call it a rainbow pattern. We'll just say that you will form like 7 different types of colors. Why? Because white light consists of 7 different colors, which is the red, orange, yellow, green, blue, indigo, violet, which is your rainbow color lah, betul kan? Which is your rainbow color, 7 colors. But then if you look at the rainbow color, you cannot find where is the constructive, where is the destructive, okay? Because when you have destructive interference, the light will hilang. So you will just get a black color, like a dark fringe, okay? The dark light. If you have constructive interference, you will get the green color light. So that's why in this case, why you got bright fringe, here, right, okay, because this is your constructive interference. Why you got dark fringe? Because that is your destructive interference. Okay, can. So once you have a color filter, is to produce light with one wavelength, meaning to say one wavelength, one color only. One wavelength, one color only. One color, one wavelength. Okay, same lah. So this is what we will observe monochromatic light. Okay. Now I want to test you guys punya mata. Okay, punya observation ah. Okay, can you tell me if I show you this picture? Can't find the exact same photo, but I'm going to just agak-agak show you one of the photo tadi. Okay. Now, which one, the X is lebih jauh? Which X is further away? Which X is further? Obviously, the red one, right? Correct. The red one, right? Okay. Why the red one, right? The line will form further. Why for the red one, the line will form further? That's a very good question, right? Okay, so now we see. Okay, now because when we look at light wave interference, one of the most important thing is you need to remember the red, orange, yellow, green, blue, indigo, violet. Okay, so this is the colors of the rainbow. Like your rainbow is red, orange, yellow, green, blue, indigo, and violet. Okay, faham, right? Now, if you want to look at this red, orange, yellow, green, blue, indigo, violet, this thing, so you will realize that the colors of the rainbow will affect something what we call the lambda, the wavelength. Okay, if you look at these lines, right, which is longest? Obviously, red light is longest, right? Paling panjang, because the red light is the outer line, right? And the inside here, your blue line, this wavelength is the smallest, right? Correct? So you got the longest wavelength, you got the shortest wavelength. So in this case, lambda equals to AX over the longest wavelength will produce the X largest. So what do you mean by that? When you see red color, guys, okay, try to take red pen and draw this thing. Try to take red pen and draw this thing. So when you look at red color, the fringes, obviously, they'll form further apart. Okay, so this is your X value, very far. But when you go to, let's say, blue color, just take a blue pen, you will realize that blue pen, okay, you can draw nearer together like that. Okay, so the blue ones, the X value are obviously shorter. Okay, the X values are obviously shorter. So the red is very far, blue is very near. Okay, meaning to say that there's a difference in gap size lah. There's a difference in gap size lah. Then purple lagi shorter. So it goes shorter and shorter and shorter. Okay, why? Because red light got larger wavelength, then blue light got shorter wavelength. So guys, you must keep these notes, because this is a very good revision material. So once you like flip back through this book, you can read through everything, then like literally you can use this to go for exams already. Okay, can, all right. Can okay, so young lion, you can read yourself out. Okay, why got bright fringe? Because this is constructive, dark fringe is because destructive. So you say blah 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 blah. Yeah, can Now, don't say coincide. Remember, it's superposition. Okay, can. Now, so okay, once you're done with this, then I think, right, based on what I've ajared you for 50 minutes, this is sufficient, cukup for you to go for your exams already. Okay. Maybe you just have to look, it's like a bit more essay question. So interference, done already. Okay, interference, done already. Okay, now what we are going to do, go to the next part, is I will teach something people don't like, okay, which is light. Okay, let me ask you a question. Okay, biasanya, your school teacher teach light, right? Okay, so they teach you the drawing first, the draw all the convex lens, concave lens. They teach you drawing first, or they teach you drawing last? Means when your teacher start teaching light, right? Do they start drawing first, or they teach you everything first, then only you start drawing? So the problem is a lot of school teachers, right, they teach drawing first, which is actually wrong. Okay, why? Because, right, okay, imagine now, guys, okay, can you draw my house? Can you draw my house? The answer is obviously cannot, unless you come to my house before, right? So the only way you can draw my house is unless you tengok my house before. So when you force students to draw without looking at first, you like students also don't know what they are drawing. So that time when you learn, like you don't know what you're drawing. Okay, today I will teach you a shortcut. Okay, so this shortcut, because I want to teach in 45 minutes habiskan this part. So it might be a bit rushy, I guess. Okay, so here you will see. Okay, if this is the cross. Okay, how do we write here? This is M, this is L, this is convex, this is concave. Okay, what is this convex, concave, ML? Now, meaning to say that when I put my pointer here, this means that I'm referring to a concave mirror. If I put my pointer here, I'm referring to a convex lens. Okay, L stands for lens. Okay, I just write L stands for lens, then this stands for mirror. Okay, now, how I usually teach my students is this thing. Okay, guys, this one very, very powerful one. Okay, tengok. Convex lens is the got belly one. Got belly one. Okay, got stomach one. Concave lens is the very thin one. Okay, got the body shape one. Okay, can So in this case, first you have to know the characteristics of image. Okay, trust me, you won't regret learning this thing. Okay, so concave lens, because this looks like Junhao. Okay, for people who see me in real life before, you will realize that I'm extremely like got the body shape one. Okay, Edward, got right? Got body shape not Junhao. Got right? Okay, so you will realize that here we will say Junhao, you very dog. Okay, what is you very dog? It means that all images, semua image that is formed by concave lens is always upright, virtual, and diminished. Diminished means become smaller. Okay? For convex lens, there is a bit more steps to it. For convex lens, you have to do this something like a special thing. Okay, what's this special thing? So convex lens is you have F and you have 2F, which is the focal point and double the focal point. So what you will write now in your book is what you call this the wrist, rim, vumi, and vum. Okay, which is called the wrist, rim, vumi, and vum. Okay, what is this wrist, rim, vumi, vum? Okay, I teach you how to use this, but first you copy down first. Okay, guys, I give you 2 minutes. Okay, you copy down this thing first. Okay, then later I test you certain things. You remember you learned this before or not? Okay, great. Okay, guys, you're just, if you're very lazy to draw, sekurang-kurangnya you screenshot, then maybe later when you need this, you will be able to refer it. Okay, can? Maybe. Okay, once you are done with eating, then let's describe. Okay, so what is the purpose? What is the kegunaan of this thing? Okay, let me show you why this thing is very important. Okay, because sometimes, right, when you learn like, you very headache, you don't know what you need to draw. You don't know what is the image that is formed. Okay, but if you use Junhao punya stuff, okay, so guys, look. So this is concave lens, correct? This is concave lens. So concave lens always form what image? So kita pergi tengok the right hand side. Vroom. It always form you very dot. Okay, you very dot means that it will always form upright virtual diminish if this is a concave lens. Okay, tak kisah where your object is. Your object can be at behind of F, in front of F, dan sebagainya. Okay, faham? So it doesn't matter. Okay. Now, so Shakira, okay, now your turn, okay. So tapi kalau if I give you convex lens, all right. So the antara 2F is between 2F and F now. So can you guys tell me convex lens is the left hand side that you draw just now? What is the 3 alphabet that is between the 2F and F? So Shakira, 3, come on, everybody. What was the 3 alphabet that was between 2F and F now? Okay, so you realize that this is R-I-M. Betul? Remark. So meaning to say that you will form a real inverted magnified image. R-I-M. So if now you form R-I-M, you will realize that, okay, then we know, oh, so the image that we have to draw is a terbalik, inverted, bigger magnified image. So biasanya when you draw something, of course you need to know, you want to draw bigger, you want to draw smaller, you want to draw inverted, you want to draw upright, you want to draw vertical, whatever lah. So you need to know what you want to draw first. Then you start drawing. Okay, so this is why you need to know the characteristics. Okay, I give you guys one more special one. Kasih special sikit. Okay, this one is now my object is at the F value here. See nampak tak? At the F value here. Now, so if it's at the F value here, what is the alphabet? I think my writing very ugly. Shakira, it is actually VUMI. It's not RUMI, it's VUMI. Okay. Now what is VUMI? VUMI stands for virtual, upright, magnified. I stands for infinity. So this is virtual, upright, magnified, infinity, VUMI. So you know that this is infinity also has something to do with telescope, which is very far one, right? Yeah, so this is what I do to actually teach my students on. So you agak-agak know what you want. Alright, can, alright. So then these two you cross, you will get your mirror already. Alright, can. Now, what do I mean by cross? Okay, the moment I cross these two, I bukan sahaja can teach you mirror and lens in less than 5. I mean, I bukan sahaja teach you lens. I can also teach you mirror in less than 5 minutes. So what is on the mirror side? Okay, we look at the mirror one. Okay, so now you all look at the quadrant that you draw just now. You look at the 4 quadrants that you draw just now. Okay, so when we look at this thing, this is a convex mirror. Okay, guys, this is a convex mirror. Betul kan? Convex mirror. So kalau if this is convex mirror, so convex mirror is where? Which side? Convex mirror is this side, right? Correct. Which is the same as this side, right? Correct. So what was the alphabet on the right bottom corner here? It was the U very dot, right? Correct. So why convex mirror is the same as the concave lens? So this is U very dot, upright virtual diminish, convex mirror. So it's actually the same thing, but terbalik. Convex mirror is the same as concave lens. Okay, magic. Okay, magic. Okay, now satu lagi special one. Okay, okay, let me show you this. So this is a concave mirror. Okay, this is a concave mirror. Now I don't tell you where to find. Okay, my object is depan F and 2F is in front of 2F and F. So concave mirror, what is the alphabet that is here? My object dekat sini. What is the alphabet that's here? It is VUM. Checking betul. Virtual upright magnified. So done, guys. Done. Virtual upright magnified. Done. Okay? Yeah. Virtual upright magnified. Done. So in this case, you will realize that, whoa, in less than 10 minutes, we managed to look at a lot of characteristics of image. So when you see characteristics of image, when you know how to see characteristics of image, then when you learn light, you won't feel like it's so pointless. You won't feel like it's so like here, what am I learning? Why like so cacat one? Why so weird one? You exactly know what you're trying to do. Okay, can so which is a good thing. Okay, now done already. Okay, let's look at some calculation. Okay, give you the pening part. Give you the pening part. Okay, Can we just look at page 11? 11. Okay, this one. Okay, so they want you to calculate the focal length, they want you to calculate the power, they want you to calculate a bunch of things, right? Correct, a bunch of things, right? Okay, so for this one, how to calculate? Okay, now how to calculate? So we got this rule, which is your focal, there's a formula, is 1 over F equals to 1 over U plus 1 over V. So there's this rule. Your U is always only positive. V ada positive and ada negative. Positive is a real image. Negative is a virtual image. Okay, F is positive and negative. Okay, what's the difference positive and negative? So usually this positive is the converging one. Okay, what's the converging one? Usually means that this is your convex lens. Then negative one is your diverging properties, which is usually your concave lens. So you better write this down. So F got two types. F got the positive F and the negative F. V also got positive image and virtual image. Okay. Real image is most of the time inverted. Virtual is always upright one. So this one is like gang already. Real inverted, virtual upright. Okay. F convex lens, converging, diverging is concave lens. So this is the idea. Okay, so now when we look at this question, okay, you want to count focal length of the lens. Biasanya, we will count the first formula 1 over F equals to 1 over U plus 1 over V. Okay, so apa ini guys, apakah ini? So you want to try and count focal length. So what is U? U stands for object distance. V stands for image distance. Okay, how to be not confused? In this world, right, guys, okay, you sing the alphabet song, okay? Which alphabet comes first? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, right? So U first, right? Correct. So U is your object because it's the first one. Image is the second one. So you have object, baru you have image, right? So U is object, V is image. Okay, faham? So now 1 over U is 1 over 12. 1 over V. So guys, what is V value? Your V value is going to be your image distance. So remember, image distance is always from image all the way to the lens. This is U, this is V. So how much is my V value? They purposely give you the whole 48. So this part, Wing Sun, your V value, how much? That's you. It'll be 36. Okay, because we'll take the 48 minus away the 12. So, okay, guys, I give you a special task. Can you calculate how much is the F value while I drink water first? All right. Okay, so you have 1 over 9. Ole to my focal length will be 9 cm. Okay. Now for this one, we not necessarily need to change to SI unit. Okay, so it's just 9 cm. Positive 9 cm. You don't write positive also can. But should the answer be positive? Yes, because this is a convex lens. So sometimes berdasarkan the answer that I get, I will check and see, my focal length is positive, so this is convex lens. That means that this is actually a correct answer. Okay, Ken? Next, what about the power of the lens? How to find out the power of the lens? This one macam mana? Okay, got strategy one. So power of the lens is there's a formula called 1 over F. But guys, listen, this focal length must be in meters. And this one must write positive, negative. Okay, why? Now, anybody here wear contact lenses? Anybody here wear contact lenses? Sure got, right? Got girls here, sure like want to like pretty, sure got wear contact lens on, right? Don't tell me you guys don't wear contact lenses. Nobody here wear contact lenses, really? Oh no, okay. Now, if you see contact lens before, right, on the box, right, they got write positive and negative one. Because usually, if you wear contact lens, means you got what? You got short-sightedness, right? Correct. So usually there'll be like a negative on the contact lens box. Now, next time I show you my contact lens. Okay. Now, so power equals 1 over F. So for this one, if it's 9 cm, to change this to meter, I have to put this as 0.09. So this is your power. So this kind of power is 1 divided by 0.09. So if my power is 1 divided by 0.09, so my power is, this is positive, 11.111. The unit is D, stands for diopter. Remember, there is 11.111 D. So the D is unit of diopter. Diopter is the power of the lens. Okay, unit called diopter means power of the lens. All right, Ken, 11.111 diopter. Okay, once you are done with this thing, once you siap with this thing, we will then go to the next part. Okay, Ken, all right. Yeah, so this is the calculation part. Okay, so far so good. All right. Now, guys, just an update. Okay, just an update. Now, you guys, some of you who probably don't know, I actually have a YouTube channel whereby I've already posted quite a lot of those very useful videos. Now, if you trust me, guys, all this pressure, gravitation, force and motion part 1, wave, there are total 4 chapters here whereby I do a lot of those state papers. It's just 30 minutes per video. I highly recommend you to go and watch. Okay, it's just like practice with me. So whereby what we do here is we just do latihan. Okay, Ken, all right. We just do latihan only. All right, so make sure you have a look at this kind of thing. Okay, it's English friendly. It's English friendly. Okay, now, okay, so once you're done with this thing, okay, I want to look at page 13. You guys, I want to look at page 13. What's the name of the channel? The channel is basically you just type my name. Yeah. Okay, Ken. Yeah, you just have to type my name. That's all I can say. Okay, now let's look here. Next part. Okay, shows a colored picture of a butterfly. A student intends to project the colored glass onto a large screen, 4 configurations, so that you can form a bright, large, upright colored glass picture. Okay, guys, here we got 4 types of projector. They want you to display all these larger, it's basically a projector, screen projector. So now, can you tell me, berdasarkan this one, all right, which is the better projector? Is it W, X, Y, or Z? I give you 20 seconds to decide. I give you 20 seconds to decide which is the better projector lens. Okay, so W, X, Y, or Z. Come on, guys, try your best. Wrong, never mind. Most importantly, you try. W, X, Y, or Z. So, Jai, Siwei, Krisha, Ziling, Edward, include, okay, we got people vote X. We got people vote Y. We got people vote W. So W, X, and Y only. Z kick out already. Okay, last 10 seconds. Shakira. Clarissa. Okay, 5, 4, 3, 2, 1. Okay. Now when we look at this thing, right? Actually, there's a cheating way on. Okay, there's a cheating way, but we don't want to look at the cheating way. Okay, so first of all, if you want to do, so this is basically a projector, right? Now, most importantly is when you learn light, the first thing you need to know is what is the difference between real and virtual. Now, you can give me all the what definition some teacher teach that what real is inside the mirror, outside of the mirror, then virtual is inside the mirror, inside, outside. Very confusing one. Okay, for me, very simple. Real means that it can be captured. Virtual means that cannot be captured. Now, what's the meaning of captured? Captured means that you can actually form on the screen. So projector, if projector needs to be captured or no need captured? Projector need to capture or not? Need, because for the projector, this thing has to be able to be captured so that you can form on the screen. So that on the screen, you will see the thing. So the answer is it has to be captured by the projector. It has to be captured by the projector. Okay, so therefore, I'm looking for a real image. Which one will form a real image? Moreover, they tell you that this is a larger magnified. So berdasarkan this thing, I'm looking for a real inverted magnified image. Okay, why? Because just now, I think some of them came in late, you all missed the most important part already. Okay, so in order to form real inverted magnified, my object needs to be between 2F and F. Okay, because read rim vumi vum. Okay, because read rim vumi vum. Now, so when we look at this RIM, which is the real inverted magnified, I want my object to be placed between F is 5 cm, then this 2F is 10 cm, right? So my object must be between 5 and 10 cm, right? Okay. So now, if 4 cm means that it's in front, right? This will form a this will form a virtual upright magnified image. But if it's 8 cm, it's real inverted magnified image. Okay, because in front here is VUM, 4 cm is here, 8 cm is here. So meaning to say, berdasarkan this thing, I can immediately eliminate. Okay, I can immediately eliminate the bottom part already. Okay, sorry, this one and this one already. I want the real inverted magnified. So you need to know how to see the real inverted magnified, virtual upright magnified. So why I need this U equals 8 cm to form real inverted magnified image. Okay. Now, do you know that, guys, in a projector, so let's say this is the projector. So when they project this person onto the screen, right? Correct. When they project this person onto the screen, so your image is obviously real inverted magnified. So kalau this is inverted, right? Have you ever thought that inside the projector, your image is your thing is actually terbalik on? Your object is actually terbalik. So your image will become the upright orientation. So if you want to show this butterfly on the screen like this, the moment your butterfly inside the projector, it has to be a terbalik butterfly. Understand? It has to be a terbalik butterfly. So this one has to be inverted. Okay, why this thing has to be inverted? So that the projected image is inverted back to the correct orientation, so that your projected image, the projected image is inverted back to the correct orientation. Means basically you flip it back to the correct orientation. Yeah, faham ah? So you basically project it back to the correct orientation. Okay, now once you are done with this thing, then at least you know how to see all this stuff. Okay, can? Yeah, okay. Now, so one tiny part. Okay, can we just look at page 16? Okay, I'll show you a very fast way on how to deciding which is the better telescope. Okay, can? All right now. Okay, for telescope and microscope, to be honest, if you want to learn how to do drawing, it's a bit confusing. Okay, we don't do drawing first. Like I said, drawing should be your last step. Drawing, not your first step. You have to know what you draw, so drawing is the last step. Okay, to learn telescope and microscope, first of all, you need to know that telescope and microscope consist of two lenses. Okay, both is convex lens. All right, why? Because you need to form a magnified image. Okay, so both is convex lens. Now for telescope and microscope, one of it is called the objective lens. The other one is called the eyepiece lens. So they always like to ask you, so my objective lens, what are power, what relationship, the distance, blah, blah, blah. Okay, so I teach you my style. Okay, my style is, in order to learn microscope and telescope, the first thing you need to do is you need to learn how to spell. Okay, telescope is Telescope. Microscope is Microscope. Okay, step one. When we look at telescope and microscope, telescope is Telescope. You see E then only O, meaning to say that the power of your eyepiece lens is larger than power of objective lens. Power of objective lens is larger than power of eyepiece lens. Faham tak? Okay. Now the P is 1 over F. The higher your power, the shorter your focal length. Your power of the lens and the focal length of the lens is terbalik one. So once we look at EO, immediately the power, focal length of eyepiece lens shorter than focal length of objective lens. Focal length of objective lens shorter than focal length of eyepiece lens. So my focal length is terbalik, my larger and smaller terbalik saja. Okay, Ken? Now the third one, they like to ask for the third one is the distance between the lens. This is called L. How far should your lens become? Okay, so this one, let me ask you a question. Some people will guess wrongly, but okay, we look at the spelling. Guys, microscope and telescope, which word is longer? Which word is longer? Microscope or telescope? Okay, microscope is like 10 words, right? telescope is like 9 words, right? So this is actually like 10 words. This is actually like 9 words, right? Correct. So you will realize that because that is longer, this is the distance L is longer than the sum of the focal length. This one length, because it's a shorter, so therefore this is shorter or equal to sum of the focal length. Now, if you want to know why, got reason, got cara, not God, but I cannot do this in less than half an hour. So I will talk about the why, but you can use this shortcut first. And then there's a special formula. To calculate magnification of microscope, this is MO times ME. To calculate magnification of telescope, this is FO divided by FE. Okay, Ken? All right, now your copy first. Okay, while you are copying at the same time, can you help me to choose which is the better telescope? P, Q, R, or S? Which is the better telescope? P, Q, R, or S? By using what you have learned on top. Okay, we got one guess already. Do we have another one more guess? Another 2 more guess? Okay, everybody gets the same answer. Okay, got one person gets different answer. Okay, so first of all, how do I filter this thing? I said already, all of the telescope, microscope, they all must use convex lens. Okay, so the first thing I filter is Q and S. Telescope. Telescope is the word E first, right? Correct? E first, right? So the eyepiece must high power, right? So the eyepiece must high power. High power. Then you see FO larger than FE, right? Because this is telescope. FO larger than FE, right? FO larger than FE, right? High power, right? Then after that, if you see this, it has to be shorter or equal to, right? Correct? So shorter or equal to can equal, can shorter. So therefore, this one fulfill everything. So my answer is Q. So let's say okay guys, let's say if worst case scenario happen, suddenly your exam, right, gonna do telescope, microscope. At least now you can answer, you can pick the correct Q. So sekurang-kurangnya in 10 marks, even if you don't know how to explain, you have gotten 6 marks. So this is actually not bad, considering you only learn this in 5 minutes. Faham? So considering you learn this in 5 minutes, is this acceptable? I think this is considered acceptable. Okay, Ken? All right. So I think this is considered acceptable. So it's not that bad. Okay, it's not that bad. So yeah, so we can get 6 out of 10 here. Okay, Ken? Ken? Okay. If you got no problem, all right, let me end my last 40 minutes we actually have 35 minutes in this thing called Archimedes principle. Okay. So can I like until sini saja? Okay. Now for Archimedes principle, okay, here you will realize that there's this thing called things you should know. So there's a bunch of things here whereby you know what is Boyle force and everything. Okay, biasanya student always underestimate Archimedes principle. They say, teacher, this one sub water easy lah, this one. Okay, but then they always make a mistake. Okay, what's the mistake here? Okay, now first let's warm up first. Why got buoyant force? Buoyant force is because there's when you displace water, something will push you upwards, then the force will go up. So you have something called water buoyancy, buoyant force lah. Okay, now this is inside, this is the water. Okay, bayangkan this is the water. If now I've got the same object, but this object is now at different position. Okay, one half outside, one is fully inside like that. Okay, so I call this two different situations lah. Okay, this is situasi A, this is situasi B. Can you tell me in which situation the object has more buoyant force? Point A more buoyant force or point B more buoyant force? Which part got more buoyant force? Buoyant force. Shakira, good try. Very good. Okay, now, not bad, not bad. Come on, do we have more people? Junkit, correct. Yihui, correct. Wing Sun, correct. What about I think? What about Erica, Kang Zhen, Kiyang, Clarissa, Krisha, Zisen? Okay, the answer might surprise you. Which has more buoyant force? The answer is B got more buoyant force. Not A, not A, Jay. Okay, why is B? Okay, a lot of people don't know this. A lot of people don't know this. Archimedes principle, which is your buoyant force, right? There's a formula called V rho G. Okay, and there is something called the weight of fluid displaced. Okay, first of all, okay, what caused buoyant force? Now, if you look at physics, they'll tell you why got buoyant force. Because there's a difference in pressure above acting on the point. Okay, we don't want to use the definition. Okay, ask you a question now. Why got buoyant force? Why got buoyant force? Okay, while I'm drawing this thing, right? Okay, can you all tell me if today, right, guys, I go to a pasar malam. Okay, I go to a pasar malam. Just imagine a very crowded pasar malam. Very, very crowded. So once I go to the pasar malam, very crowded, a lot of people in front of me, right? Then you know what I do? I start pushing the people in front of me. What will happen to Jung Hao? So when I go to pasar malam, okay, I see a lot of people. So what I do now is I push the people away. So what will happen to Jung Hao? What will happen to Jung Hao? Have you ever tried like go to a very crowded place, you push someone, and then immediately you will realize that you cannot push backwards like immediately one. Okay, why? Because when you push, the other side will push back, right? Okay, so what happens here is that, okay, imagine now there's water here. Okay, when you take this spring balance, okay, bayangkan this spring balance, let's say here written 10 Newton. If now I take this spring balance and I kasih celup into the water, so the water, extra water will flow out, correct? Extra water will flow out. So all this water, right? They will say like, wait, brother, you push my gang keluar lah, because water and water friend, right? So the water here will say, wait, you push my water friend out, is it? So what will happen to the surrounding water? So now they will gang you out, okay? So they will try to punch you back. Okay, they will try to punch you back. So that's why this creates the buoyant force. Okay, Ken? Now, buoyant force is actually equals to the weight of fluid displaced. Means we need to say, you push how much water out, you push how much water come out, then how much force will be acted back on you. If you push more water out, more people will punch you back. You push harder in the what pasar malam, more people will punch you. Okay. So therefore, in this A and B, let me ask you a question. Who push more water out? Siapa push more water? Obviously B, right? Correct. Because we compare the volume of the object submerged in the water. So in this situation, in this situation, B actually has a larger volume of water submerged. So therefore, B actually has a larger buoyant force than A. So this is why, right, Jai? If you push, let's say, an empty bottle. Okay, imagine this is empty bottle. So if you push this into the water and you let go of the hand, the bottle will bloop. It will bounce up one, right? Correct? It will bounce up, right? So why it will bounce up is because as it bounce up, that's due to this thing called the buoyant force being larger than the weight. The buoyant force is larger than the weight, so it bounces all the way up. Okay, can faham ah? Well done. Well done, no problem. Okay, so what's next, guys? What's next? Okay, next is going to be, we look here. So V rho G, remember, this density is the density of the fluid. Now, why do we use the word fluid? Because fluid actually means that this includes gas and liquid. So gas dengan liquid, both is part of fluid. So here you will see lah, okay, we will usually take the volume of the object submerged. Rho is the density of the fluid. Dan sebagainya. Okay, can Okay, I show you one sample calculation, okay, for Archimedes principle. Okay, because Archimedes principle is not easy. I don't know why people think that this one very simple to calculate. Okay, now, so let's just look at page 22 first. Page 22. Okay, so here they show you, this is a model of a sampan that's used to ferry passengers. Now, the sampan will sink if the water level exceeds line WR. So meaning to say that the water maximum can sampai line WR only. Okay, so the mass and average surface area of the sampan is 100 kg and 2 meter square completely. Calculate the maximum mass of passengers that can be ferried without exceeding line WR. Density of river water is 1000 kg per meter cube. Okay, this is page 22. PG 22. Okay, while you look at this calculation, right? Okay, guys, tengok we want to find if this thing is completely, fully masuk ke dalam water. All right, so never mind. You just look at this one first. Okay, if you are fully inside the water, how much buoyant force can you produce first? How much buoyant force can you produce first if you are fully inside the water? Okay, now, so I've got the height here. The height here is actually how much? This is actually 0.38 meter, right? Because there's the depth 0.12 on top, so water is 0.38, right? So volume here is actually 0.38. We take the 0.38 multiply by what? The 2. Okay, why? Because your volume is actually equals to area times height, right? Volume is equals to area times height, right? So then you multiply already. Density berapa? Density of water is 1000 kg per meter cube. Gravity is 9.81. So you get your buoyant force in terms of blah, blah, blah Newton. Okay, when I mean blah, blah, blah Newton, you have to press this out first. Okay, good. Volume is pi r square h. So volume times height. So 0.38 times 2 times 1000 times 9.1. So my buoyant force here is 7455.6 Newton. Okay, okay, meaning to say that the total buoyant force that can go up is now 7455.6 Newton. Okay, total buoyant force that can go up is 7455.6 Newton. Okay, what about the weight of the sampan? Okay, so now we know that the weight of the sampan. Okay, guys. So 100 kg is how many Newton? Come on, check it out. 100 kg is how many Newton? Very important, It's mg, right? Okay, so 100 kg we multiply by 9.81, right? So therefore the answer is 981 Newton. Okay, now so I've realized that this is 981. Okay, so now my boat can produce 7455.6 Newton going up, but the weight of the sampan hanya 981 Newton. The weight of the sampan is only 981 Newton. So now, can you tell me how much more people can I fetch? How many more people can I fetch? So what I can do here is, so this is the people that I can fetch, right? So what I do now is, I can fetch extra 7455.6 minus 981 Newton. Okay, kenapa? Imagine that now the total force go up is 7,000. But your boat only 900. So I can fetch extra people. Okay, what I want to do here is I want the top and bottom to be equals. So I 7455.6 minus 981. My total force is 6,400. My force is 6,474.6 Newton. So meaning to say that I can fetch additional 6,474.6 Newton. Okay. Now, but Ziling, why is this not my final answer yet? Why is this not my final answer? Okay, very good. Yeah. So what I'm trying to do here, they want me to find what is the maximum mass of passenger. So this is the fetch. I can fetch 6,474.6 Newton, right? So now I have to tukar balik kg. So I have to change back W equals to mg. So 6,474.6 equals to m divided by 9.81. So that is the mass of the passenger, which is okay, trust the answer. So 660 kg. So this is the human that I can fetch. All right. So that's why, right? Don't you dare assume that this bug or this subtopic is very easy, because this subtopic is actually not very easy. Alright, this subtopic lah, the whole chapter okay lah, not susah because Pascal principle very easy, but the belakang one slightly more complicated, which is this one and the Bernoulli actually also quite complicated. Depends also quite complicated. Okay, I can okay, so if you have no problem, then jom kita pergi tengok page 24. Page 24. Okay, this will be our last question for today. Okay, this will be our last question for today. Okay, can you guys explain to me agak-agak how hot air balloon can float? How hot air balloon can float? Okay, if teacher asks me why hot air balloon can float, can I write because hot air is less dense, so therefore hot air balloon float? Boleh tak? Can I write like that? Because hot air is lighter, so hot air rises, so hot air floats. Can or not? Is it acceptable? The answer is not acceptable. Tak boleh. Okay, why tak boleh? Kenapa cannot? Okay, the reason is very simple. Okay, why I say cannot? Okay, because when we look at hot air balloon, can I say that if I take a balloon, I go to 7-Eleven, I buy a balloon, okay, balloon. So I put a candle inside, so I have a hot air balloon. Okay, I buy a balloon, I put a candle into the balloon, then I like that pray that I will fly. Can or not? The answer is it will not fly, Okay, kenapa it will not fly? Because the whole concept bukan hot air rises. Okay, now first of all, why hot air balloon can fly is, okay, now one more question. Hot air balloon, right, must rise in the morning. Okay, you need outside to have hot air, or do you need outside to have cold air? In order for your hot air balloon to rise, your luar must be hot air or your luar must be cold air. In order for it to fly. Your outside must be? The answer is the outside must be cold air. Okay, this can be quite surprising for some people. Okay, why must be cold air? Okay, if you all say, let's say Shrita, if you say hot air, then the hot air balloon can fly, right? Shrita, do you know Malaysia famous for what? You know you live in a country which is famous for hot, right? Malaysia famous for hot. Look at the weather today, hot, right? Then if hot is better, then why Malaysia very rare hot air balloon? Why Malaysia very rare you will see hot air balloon? Because in order for a hot air balloon to rise, you need cold air. That's why if you go to Turkey and see hot air balloon, The time of launching is usually early morning when the air is cool. Okay. Yeah, it is early morning when the air is cold. Cold or cooler or cold can. Okay. Now, why do you need the surrounding air to be cold? Okay. Because here we talk about buoyant force. So buoyant force, we got this thing called V rho G, correct? Now, this rho, which is your density, do we use the density of the inside, or do we use the density outside? Which one, guys? This rho is the density inside or density outside? So we will usually use the density of the outside one. Do you know that? Kenapa? Okay, because we say this is the density of displaced. Displaced means kena push. So when you have a hot air balloon, your hot air balloon is pushing outwards, right? Correct? So which air kena push is the cold air. So when the early morning, when the surrounding air temperature is cold, you will have a higher density of air. So therefore, your buoyant force is higher. That's why your hot air balloon is more likely to float when the surrounding density is higher. So when you have a higher density of air, your buoyant force is larger. Okay, so we are looking at this place. So this is your cold air outside. Okay, Ken? All right. So this is the density of outside. Okay, then let me ask you a question. What is the purpose? Why inside must have hot air? Okay, whether will inside punya hot air affect the buoyant force? Can I say the temperature of air in the balloon must be hot so that the buoyant force increase? Can or not? So why do we want our balloon inside to have hot air? Kenapa? Okay. Now there are two reasons. Okay, number one, we actually want this hot so that the balloon will expand. So when the balloon expands, it will push the outside air. So when the outside air kena push, you will kena displace, then you will have more buoyant force. Okay, in that sense, yes. But it's better to say that, okay, the answer is we want the temperature of air in the balloon to be higher temperature. Okay. Now to be higher temperature. Why? So that the density of air inside decreases. So if your density of air inside decreases, the mass of air decreases. So your hot air balloon becomes lighter. So when we put hot air inside, we are actually trying to make the hot air balloon become lighter. So one of the main problems that why you cannot make homemade hot air balloon is because you need to make sure that the inside is very hot so that it becomes very light. Okay, remember, hot air makes the balloon lighter. Cold air makes the buoyant force larger. So it's different factor. It's a different factor. Okay, can Okay, then after that, next, what about the quantity of the burners? So in this case, obviously, is we want to have more burners. So why more burners? So that you can heat up air inside to higher temperature. Yeah, to higher temperature. Then after that, what about material used for the balloon? Okay, guys, can anybody tell me what should be the material used for the balloon? Okay, come guys. Can everybody come? We are almost at the end already. Can you all just like try to suggest? So the material for the balloon must use what? Okay, Shrita say must use rubber. Junkit say must use nylon. Okay, ada lagi tak? Nylon, rubber, light and strong, Edward. Okay, the material used polyester. Okay, remember, we usually state the characteristics. Don't tell me the name. I repeat, we want the characteristics. Don't tell me the name. So we usually, okay, why? Because takkan you say what, fabric with rubber campur with a bit of nylon, then the tepi must use plastic with a ring and whatever. No need, guys. You don't need to like, you bukan tulis karangan, okay? You just have to, although this is an essay question, you just have to say that it has to be a light and strong material. Ataupun, you can even say that it has to be a fireproof material. Because why? Imagine you fly your hot air balloon halfway, right? Suddenly the api, right, the fire, terkena the side of the balloon. So if terkena the side of the balloon, the whole thing will burn. Then this thing, your hot air balloon will just jatuh, fly, then all the way drop down, then you die. Okay, then tak boleh lah, of course. Okay, so you must fireproof, light and strong. Apa lagi? What else? Light and strong, fireproof. Okay, another one more they accept is elastic. But for me, I don't like to write this thing because it's very lecture to explain. The elastic is so that when you expand, when it's heated up, the hot air balloon can expand. So if it can expand, the volume can increase. Okay, can, all right. So, but I don't like, I prefer light and strong, fireproof, waterproof, and so on. Okay, better than the other answers. Okay, lastly, okay, what about the size of the balloon? Okay, size of the balloon obviously is larger size of balloon. Okay, why you want larger size? So that you can increase volume of air displaced. Hey, guys, don't just write increase volume. Because you have to say increase volume of what? You want to increase volume of air displaced so that you can increase your buoyant force. Okay, can, all right. So I write on top here in exams, you all have to write down, okay? Form 4, I got teach them how to write essay. Okay, Form 4, I got teach them how to write essay. But Form 5, do you need me to teach you how to write essay? No need, right? Okay, can, no need, right? Okay, so okay. Now, so next, okay, so this one done already. Okay, just now I promise you this is the last question, right? Okay, but I just want to do one more small thing because that time, right, this came up in your exams. A lot of people actually got it wrong. So I just want to like very quickly talk about this as an example. Okay, if you don't mind, I'm just gonna talk about this as an example. Okay, can you look at page 26? Okay, we just verbally do this and then end of story. Okay, now can you tell me? I have to design a sound system. We got J, K, L, and M. Can you tell me which is the better sound system in the hall? J, K, L, and M. Which one better? J, K, L, and M. Yang mana lebih bagus? Better. J, M. Lagi. Keep the ball rolling. M. Okay. So in this case, you will see. Okay. Let me ask you a question. Where should be your microphone? In front of the loudspeaker or behind the loudspeaker? Okay, so this one, right, has something to do with the, you know, when you're sometimes Monday morning, your pengetua, you all still got assembly, right? So when your pengetua like selamat pagi semua, then you have the very loud sound. Okay, now why? Okay, remember this thing, guys. Okay, if today Jun Hao is having a concert, okay, I can sing one, okay? So I'm having a concert. There are two choices. One is my speaker. This is my speaker that produces the sound. Okay, these are all my fans. My fans. So my microphone is behind the loudspeaker. Okay, this one. So another option is my speaker dekat belakang. So I'm closer to my fans. Okay, so which one is better, guys? So obviously, this one is better. First one better. Okay, why? So, okay, I see most of you choose M. Okay, I think the answer is correct, maybe, I don't know. Okay, but why you want to be behind? Okay, you want to mengelakkan what? You want to avoid what? There's a proper term one. Okay, so we want this behind the loudspeaker. What do you want to prevent? Not echo. Echo is wrong. There's a proper term one. No, it's not reflected. Okay, why? You takut because when you sing into the mic, when the sound go to the loudspeaker, it masuk the mic again, and then it goes back to the loudspeaker again. You don't want this cycle to happen. This cycle dikenali sebagai apa? What you want here is that when you talk into the mic sends out, so the sound goes out, habis, end of story. So, why? What? Apakah? Okay, so the jawapan here that we are looking for is, we want it is to prevent sound from, you're preventing the sound from the loudspeaker to feedback. Feedback is the word that they want. Feedback into the microphone. You want to avoid the feedback. Feedback is the word. Feedback means the sound is re-amplified again. Masuk the loudspeaker. LSPK is loudspeaker. To feedback into the microphone. So you will have this like that. Okay, Ken? All right. Now, this is not echo. Walaupun people say, ada echo. Bukan, echo is reflection. Okay, why this you have to use softboard? Okay, don't straight away say, the sound, the surrounding must be soft to prevent echo. Cannot. You must say that here, you are trying to reduce the reflection of sound to prevent echo. Echo is the last term. Remember, when you write physics answer, you must have physics terms like reflection of sound. Okay, can. So echo, if you just write echo, tak cukup one. Because if you say to prevent echo, what causes echo? Why will there be echo? Because there's reflection of sound to have echo. Okay, so this one very important. You must say physics term first. It's just like, right, another thing I'm very angry one. Okay, let me ask you a question. Your form 5, you all know this, right? Okay. In a lot of essay, we always say low density, correct? Then if you see the schema jawapan, they will say, oh, because this is lighter. Okay, do you know this is now officially diharamkan already? Why low density cannot straight away write lighter? Because what is lighter? Lighter is what the got fire, the lighter is it? So what must you write before you write lighter? So this one, you sure know one. So when we say low density, before we write lighter, in front we have to add a term. Then we can only write lighter. Yeah, so then we must say that there was a lower mass. So mass is your physics term. So when you want to say echo, you must say reflection of sound to prevent echo. Okay, there must be a physics term, that only a normal term. All right, okay, let's say for example, okay, so location of the loudspeaker. Why is it that when we want to listen to speech, why the speaker must be hanged higher? You cannot just say like, so that can listen. Okay, if you see, just now I draw, right? Why my loudspeaker must be on top is because if this loudspeaker is now on the ground, this sound keluar, the first guy will hear, this guy will be like, huh? What am I listening to? What am I listening to? So what should be the proper way is this loudspeaker should be on top. So when the sound keluar, everybody will be able to hear. Okay, so this is to avoid, or so that to prevent sound. You're trying to prevent the sound from being blocked by obstacles. Okay, you're trying to prevent the sound from being blocked by obstacles. Also, your sound can prevent it being blocked by obstacles so that it can travel further to the back so that the people at the back can listen or can hear something like this. Okay? Okay, last part. Why this loudspeaker must be wider. If you all can answer this question, means today we very successful already. If you answer this question, means today we very successful already. So what is the reason? Here, last question. So Edward Chow, Irving, Wingstone, bigger sound wave can cannot lah, cannot. Cannot say better spreading. Oh my god, guys, I want to like explode already. You punya answer are very cacat lah. Okay, now this distance between loudspeaker is related to interference. Berdasarkan lambda equals to x over d. The distance between two loudspeaker is a, x, d, or lambda. No, this is a. A. Okay. So in this case, okay, in a hall, okay, you will see that in a hall, you will realize that now we got wave galore. So this is the two speaker. These two speaker, the distance between these two speaker is A. The further, the better. Lebih jauh, lagi bagus. Okay, why? Because what we want here is, you know, the loud sound and the soft sound, the loud sound and the soft sound, the constructive and the destructive. You want your X value, the loud to loud. Do you want your X value to be larger or to be smaller? You want your X value to be further or nearer? Okay, bayangkan this hall. So if very far means this is loud sound, this is soft sound, this is loud sound, this is soft sound, this is loud sound, this is soft sound. So the people here will be like, what the hell? Like, why so soft? Okay, another one more option is we do this. We loud, then soft, then loud, then soft, then loud, then soft, then loud, then soft, loud, soft, loud, soft, loud, soft. So that, right, the X and X is very near. So meaning to say that the people will be more likely to accidentally position himself at the louder section. Faham what I mean? So means this guy is more likely that it will position itself at the louder section. So means that it will go to the louder part. So what we want here is we want the X value to be as short as possible so that it is nearer. So that you will have more loud sound. Okay, if you count here, got 1, 2, 3 loud sound. If you got like 1, 2, 3, 4, 5, 6, 7 loud sound. So you actually produce more loud sound. Now, which is obviously better lah. Okay, can? Now, so now this one, you want your A value. Where I do this here just now. Okay. So when I want my A value to be bigger, so that my X value will be lower lah. So when my X value is lower, so the better lah. So here how to explain. Okay, we want this to be larger so that the distance between consecutive loud sounds are nearer so that more loud sound is formed. Okay, distance between consecutive loud sounds are nearer so that more loud sounds are formed. So that means that your people there boleh dengar more loud sound. You're able to hear loud like that. If too far is loud, very far away, then we have one loud. Okay, which is then not good because very hard to dengar. Okay, Ken, all right? Yeah. Wider and further region. Okay, so for me, right? Okay, it depends on which school are you from also. Okay, like last time, okay, because I'm from Catholic, so my school teacher very particular. So you say can transfer to wider region. Why can transfer? Why higher can transfer? Because you will prevent the sound from being blocked by obstacles. So higher. So therefore, that only, right? So therefore, can travel further. Yeah. Like that. So the can travel further is like the behind part. Yeah. Okay, can then hope this answers your question. All right, so more last one is form. So okay, by the way, people who don't know me, right, you will realize that my answers for essay, right, I usually write very long one. So why I usually write very long is because I prefer that the longer you write, the higher chance you will kena the scammer. So to me, the more terms you write, like for example, sometimes, right, some books or they just say, why this one must be, why your A must be larger. They just straight away say X decrease so that distance are nearer. Why I write more lapsang is form because that is the real reason. I bukan sahaja want the lapsang to be nearer. I also want to form more lapsang. So that is the advantage lah. Okay, Ken, all right. Now, guys, today is just a 2-hour session. I think 2 hours is just nice, okay, for you all, because I know you're mentally very tired already. You're sudah tak boleh already. But if given a choice, I want to make this to 3 hours. But I think you are mentally too tired for this lah. All right, Ken. So I don't want to force the issue. Okay. Before I end, I just want to tell everybody. I will be posting some extra videos. So currently on my YouTube channel, I have about all these, all these like main chapters are gravity, pressure, wave, force, 4 chapters, which can be used for how to say revision. You all can watch this anytime when you want to. Okay, Ken? All right. So if you have any questions or what, I will upload on my YouTube channel. All right. So anybody have questions? So if you guys got no question, I will sampai sini saja. I'll see you guys again, hopefully one day. So bye everyone. Bye-bye. It's okay. Bye. Okay lah. Bye-bye. Ziling, 90 marks is good enough already. Okay. I don't expect, I mean it's healthy lah, okay. Yeah. To me, 90 and 94 and 96 is the same. I can. So 在我心目中 you very 厉害 one. Alright? Yeah, alright, don't worry. Okay, can. Alright, bye-bye.